Hello everyone, this is Divyank Nilwal. In this video, we are going to quickly revise indices and surds. And after that, we will solve some of the questions from the past papers, which will definitely cover most of the type of questions which could be asked in your exams coming. So don't forget to subscribe to our channel. And let's begin.
So let's start our revision of indices and surds. We'll start with laws of indices. As you can see, these are the laws of indices. So we have a to the power of m into a to the power of n is nothing but a to the power of m plus n. Obviously, you can just take an example. Like for example, if I have 2 to the power of 4 into 2 to the power of 3. So at the end of the day, it's 2 into 2 into 2 into 2 and then into 2 into 2 into 2. So that is nothing but there are 7 2, so it's going to be 2 to the power of 7, which is nothing but 2 to the power of 4 plus 3. Similarly, you can try out a to the power of m upon a to the power of n is nothing but a to the power of m minus n. Now, also if I have a to the power of m to the power of n is nothing but a to the power of m into n. Again, we can take an example. So for example, if I have 3 to the power of 2 to the power of 3, this is nothing but 3 to the power of 2 into 3 to the power of 2 into 3 to the power of 2, which is nothing but 3 to the power of 6 according to our first law. Also, anything to the power of 0 is 1. Because of that, we can find out that 1 upon a to the power of m can be written as a to the power of 0 upon a to the power of m, which is nothing but a to the power of 0 minus m, which is a to the power of minus m. For example, 1 upon 2 to the power of 7 is nothing but 2 to the power of minus 7. These are negative indices as well. This is the sixth rule, which is not a law actually. So, but it's a common sense. If I have ABC to the power of m, I'll distribute the power to each element. So basically, m will be given to this A, it will be given to this B, it will be given to this C. So finally, we'll get a to the power of m into b to the power of m into c to the power of m. There are certain things you need to learn. That is, it's not highlighted properly, but as you can see, 2 to the power of 1 is 2 to the power of 10, 2 to the power of 1 to 2 to the power of 10. That's what I want you to learn so that it will be easier for you to solve the problems. And for that matter, even if we have 3 to the power of 1 to 3 to the power of 4, that also you can learn. And 3 cube, 3 to the power of 4, whatever, these things you need to learn. Now, whenever you will come across any of the questions, for example, this thing 625 to the power of 2 plus 2x, you will convert this 625 in the smallest index form. For that matter, if I have 81, I know it is nothing but 9 square, but I would always prefer make it 3 to the power of 4 because I told you that you need to learn all these things. Now, the second part of this topic is surds. So in surds, what we have, so if we have, these are the properties of surds. So when it comes to multiplication, that is root 3 into root 5. So that is nothing but root of 3 into 5 you can combine in multiplication and division. That's going to be root 15. And for that matter, if I have root 3 divided by root 5, it's going to be root 3 by root 5, which is root of 3 by. In short, can combine multiplication and division, as you can see I have written here. Right? So sometimes, the question would be like root 18 upon root 2. So definitely you can write this thing as root of 18 by 2. You can cancel this with this and you will get root 9, which is nothing but 3. Now, but when it comes to addition and subtraction of surds, you cannot add root 3 plus minus root 5 as I've mentioned here, because the thing is, these are just different x and y you can consider. So you cannot combine just x plus minus y as x, y, I don't know, whatever it is. And similarly, if I have, but if I talk about x into y, yes, we can definitely combine. It's going to be x, y. So maybe you can relate that with algebra. The addition and subtraction would be something like this. If I have root 3 plus 3 root 3, that is nothing but x plus 3x, which is nothing but 4x. So it's going to be 4 root 3. Same goes with subtraction as well. Obviously, there is also a distributive property of surds. So if I have root a into bracket root b plus minus root c, so definitely you can just distribute the things and you can just solve it. Okay, now I have given one of the example for this. So if I have root 3 upon root 6 into root 2, definitely when it comes to addition, when it comes to multiplication and division, you can combine all the things and then you can solve it to get the final value 1 by 2. The major part of this topic is rationalizing. Now, one of the questions will definitely be asked in your exams. So what is rationalizing? In simple words, we don't want root in the denominator. So if I have 1 by root 2, I won't write it as 1 by root 2. I want it to be something apart from roots in the denominator. Yeah, makes sense. So in short, if I have 1 by root 3 for that matter, so 1 by root 3 is going to be what? So we don't want root in the denominator. So what I'll do, I'll just multiply the denominator with root 3 and I'll multiply the numerator as well with root 3 because I don't want to change the value. So this is going to be root 3 by 3. No problem. So no, see, I don't care whether I get root in the numerator, but I do care if there is a root in the denominator. So what I mean to say, I don't want root in the denominator. That's it. That's the thing about rationalizing. But when it comes to some difficult problems, as you can see here, when it is root 5 plus 3 root 2 upon root 3 plus 2 root 2. So what I'll do, I'll multiply by the conjugate. This is known as the conjugate of the multiplication. So if I just multiply by the conjugate, the thing is, at the end of the day, I'm just multiplying by 1. So because, but when it comes to something like this, root 5 plus 3 root 2 upon root 3 plus 2 root 2, as you can see in this question. So what we'll do, we cannot multiply by root 3 plus 2 root 2. So, but we will multiply by the conjugate of the denominator. That means what? If it is root 3 plus 2 root 2 here, I'll multiply by the root 3 minus 2 root 2. The reason being, because we know that is a minus b into a plus b is nothing but a square minus b square. So the thing is, if there is a root here, it will be root 3 square, and if there is a root here, it's going to be 2 root 2 square. So in short, we are going to multiply with the conjugate, so that, because as I said that we don't want root in the denominator, numerator I don't care. Okay, so here as you can see, if I just multiply by the conjugate, so I'll get root 3 whole square minus 2 root 2 whole square. So root 3 square is nothing but 3, and root 2 root 2 square is nothing but 8. But if you talk about the numerator, in numerator you will have to solve it. So you are actually multiplying these two brackets like this here, as you can see, and then you'll have to use the distributive property just like a normal algebra. So root 5 will be multiplied by this thing plus 3 root 2 will be multiplied by that thing. You will solve it and you will get the answer. At the end of the day, in denominator we are not getting root, numerator is all about the simplification. So this is what we have in indices and surds. But the thing is, the questions will be asked based on these prerequisites which are required, that is sine rule, cosine rule, area of triangle, trigonometric ratios. These are all based on trigonometry. Then we have quadratics, that you can find out those things, and then area and volume sometimes. And for indices you need simultaneous equation and linear equations. So these are the prerequisites for this topic. Now what we'll do, we'll start with our past paper questions. So I will be selecting 5 to 6 questions which are of different types, and we will just try to solve these questions. Now let's start with some of the past paper questions. So I've selected some of the question papers. So this is the question number 1. This has been asked in November 20. So this is a very basic question. As you can see, it's root p times qr square to the power of 1 by 3. If you want, you can try it by yourself first and then you can verify. So p to the power of minus 1 r cube. Now the thing is, what we'll do, first of all, we'll just convert everything in the fractional indices and all that type. So we'll just make root p as p to the power of 1 by 2. And as I told you, this distributed, like the power will get distributed over all these things. So this will become q e to the power of 1 by 3 into r to the power of 2 into 1 by 3, which is nothing but 2 by 3. These are all just the laws of indices, which is here, as you can see. Now in the denominator, this is going to be what? I'll just multiply minus 1 inside. So it's going to be q to the power of minus 3 into p to the power of minus 1 into r to the power of 3 as it is. Now what we will do, we'll just combine all p's, q's and r together. So we'll get p to the power of 1 by 2, we'll combine with p to the power of minus 1. This is going to be p to the power of 1 by 2 plus 1 into q to the power of, this is going to be 1 by 3 minus of minus 3. This is again laws of indices we are doing. A to the power of m upon a to the power of n is nothing but a to the power of m minus n into r to the power of 2 by 3 minus 3. Finally, what we'll get p to the power of 3 by 2 into 1 by 3 plus 3 is going to be q to the power of 3 1 by 3 or 10 by 3. And this is going to be into r to the power of minus 7 by 3. So they have just asked you to write it in this form, and this is how we will get. Now question number 2. This is based on indices again, but here there might be simultaneous equation which we need to solve. So it will be of 5 marks. So let's see. Now the thing is, in the first equation, a to the power of p plus 1 upon 4 to the power of q is equals to 2 to the power of 11. As I told you, you have to convert everything in terms of the least power, like basically 2 to the power of something you need to make it. So 8 to the power of p plus 1 can be written as 2 to the power of 3 to the power of p plus 1 as it is, upon 4 can be written as 2 to the power of 2, q will be as it is equals to 2 to the power of 11. I'm just solving the first equation. So this is going to be 2 to the power of 3p plus 3. Make sure that you multiply this 3 here as well as here, so you get something like this, upon 2 to the power of 2q as it is, and this is nothing but 2 to the power of 11. Now the thing is, this can be written as 2 to the power of 3p plus 3 minus 2q is equal to 2 to the power of 11. Now see, 2 to the power of x is equal to 2 to the power of 3, then x is equals to 3, right? So similarly, 2 to the power of something is equal to 2 to the power of something, both are going to be equal. So in short, this thing will be equal to this thing. So we'll get what? We'll get 3p minus 2q plus 3 is equal to 11, or I'll get 3p minus 2q is equal to 8. Now similarly, we'll solve this equation, this 3 to the power of, and we will convert everything in the terms of 3 to the power of something. So this is going to be 3 to the power of 2p plus 5 as it is, upon 27 can be written as 3 to the power of 3 to the power of 1 by 3. And this can be written as 3 to the power of 2 to the power of 3q. So we'll get what? We'll get 3 to the power of 2p plus 5 upon, this is nothing but 3 to the power of 1 is equals to 3 to the power of 6q. 2 and 3 will get multiplied. In short, I'll get 3 to the power of 2p plus 5 minus 1 is equals to 3 to the power of 6q. And we'll get what? We'll get 2p plus 5 minus 1 is equals to 6q. Or finally, I'll get 2p minus 6q is equals to minus 4. So as you can see, we'll get this one equation and this second equation. And now we'll just solve both the equations simultaneously to get the answer. So we have 3p minus 2q. So I'll just multiply this by 3. So I'll get 9p minus 6q is equals to 24. I just multiplied this equation 1 with 3. And this is equation 2. I'll just keep that equation 2 as it is. This is going to be 2p minus 6q minus 4. Sorry, equal to minus 4. I'll subtract. I just made the q coefficient same. So 9p minus 2p is nothing but 7p, and 24 minus minus 4 is nothing but 28. So I'll get p is equals to 4. This value, of course, you can put it in any equation, and I'll just put it here. So I'll get 2 times 4 minus 6q is equals to minus 4. And I'll get 8 minus 6q is equals to minus 4, or I'll get 6q is equals to 12, or q is equals to 2. Most of the time, whenever there are simultaneous equation and if you get integers as your answer, 95% of the time you are right. But in case if you get a fraction, just verify one more time whether you have done it properly or not.
We have done a couple of questions from indices. Now let's start the questions with respect to Surds. So as you can see, I have selected one question which is like normal calculation. So let's see. So here, as they have given, find integers p and q such that p upon root 3 minus 1, whatever this equation is. So we'll start with the left hand side. So we'll get p times root 3 plus 1 by cross multiplication plus 1 times root 3 minus 1 upon, as you can see in the denominator, it is root 3 minus 1 into root 3 plus 1. So it's nothing but a minus b, a plus b. So it's going to be root 3 square minus 1 square is nothing but q plus 3 root 3 as it is. Now, p will be multiplied over here, just like a distributive property. So it's going to be p root 3 plus p plus root 3 minus 1 upon, this is nothing but 3 minus 1. So which is nothing but 3 minus 1. I'll just make it as 2, which is q plus 3 root 3. And now we'll just move this 2 to the other side. We'll get p root 3 plus p plus root 3 minus 1 is equal to 2q plus 6 root 3. Now the thing is, here as you can see, there is some terms with respect to root 3, there is some integer terms. So what we can do, we can like in short, I want to say if I have a plus b root 3 is nothing but c plus d root 3, then that means what? A is equals to c and b is equals to d. So similarly, what we'll do, we'll just distribute like that, we'll just keep the integers together. So p minus 1 at the end, it's going to be an integer plus, and this is nothing but p plus 1 root 3. I just took out root 3 common and I got this thing. This is nothing but 2q. Again, it's going to be an integer part, and this is plus 6 root 3, which is a third part. Now what we'll do, we'll just equate this p minus 1 with this 2q, and we will just equate this p plus 1 with this 6. So we'll get what? We'll get p plus 1 is equals to 6, or I'll get p is equals to 5. I'll use this here. I'll get 5 minus 1, or p minus 1 is equals to 2q. So I'll get 5 minus 1 is equals to 2q, or q is equals to 2. That's our value. These are the values of p and q. Let's start with question number 4. In that, I have taken the basic rationalizing problem. So you just need to simplify this thing. So what you will do, Sometimes they will ask you write in the form of a plus b root 5 where a and b are integers or a and b are rational numbers. So that can also be asked. But here what we'll do, we'll just simply rationalize. As you can see, we don't want root in the denominator, so I'll just multiply by the conjugate as we have done here. So we'll just multiply by 6 minus root 5 upon 6 minus root 5. At the end of the day, I'm not changing the value. That's the most important part. So in denominator, what we'll get? Simply I'll get 6 square minus root 5 square. Again, a minus b, a plus b type. Okay, but in numerator, we'll have to simplify. So we'll get 5 plus 6 root 5 times 6 minus root 5. So again, in denominator, what I'll get? In denominator, I'll get 36 minus 5. So let's keep it as it is. Here, 5 will be multiplied with the first bracket. 5 will be multiplied by this bracket and 6 root 5 with this bracket. So I'll get 5 times 6 minus root 5 and plus 6 root 5 times 6 minus root 5. Finally, I'll just distribute it like 5 into this thing, 5 into that thing. So I'll get what? 30 minus 5 root 5 plus 36 root 5 minus 6 into root 5 square. Now pay attention here. 6 root 5 when I multiplied with this root 5. So 6 was as it is, but root 5 into root 5 became root 5 square. Denominator is going to be 31. This irritates a lot. Huh? You have to write denominator every time. Now we'll continue. So we'll get 30 plus, so we'll just simplify this thing. We'll get 30. And as I said, minus 5 root 5 plus 36 root 5. It's nothing but minus 5x plus 36x, which is nothing but plus 31 root 5. And this is 6 root 5 square is nothing but 5. So 6 into 5 is nothing but 30. So minus 30 upon 31. So as you can see, 30 and minus 30 will get cancelled. I'll get 31 root 5 by 31. I'll cancel this 31 and I'll get my final answer as root 5. So this is just the simplified form. So this is question number 5. In this, as you can see, they have given a triangle with the height and base as just some surds. You just need to find the area of this triangle ABC. So we know that area of triangle ABC is nothing but half into base into height. So here we'll just use the formula. See, the main objective of this question is to just simplify surds. That's it. So base first. So it doesn't matter, but still 2 plus 4 root 3 times 5 minus root 3. Half into base into height. Now see what I'll do. I'll just multiply half in the first bracket so that just to make it easier. So it's going to be what? It's going to be 1 plus 2 root 3 into 5 minus root 3 as it is. Now we'll distribute 1 over this thing and then 2 root 3 over the second bracket. So I'll get 1 times 5 minus root 3 plus 2 root 3 times 5 minus root 3. Now what I'll get? So once I multiply 1 inside, it's going to be as it is. So 5 minus root 3 and 2 root 3 again will be multiplied by 5. So it's going to be plus 10 root 3. And 2 root 3 with minus root 3 will give me minus 2 into root 3 square. Now 5 will stay as it is. Minus root 3 plus 10 root 3 is nothing but just like minus x plus 10x, which is nothing but plus 9x. So it's going to be plus 9 root 3. Okay, and this is going to be minus 2 times 3, which is 5 plus 9 root 3 minus 6. And finally what I'll get? I'll get 9 root 3 minus 1. That's my answer. Now let's talk about the part B of this question. So what they have said, they have asked you to find tan of ABC, like basically this angle theta. They're asking tan of this angle. Now the thing is, since it's an isosceles triangle, so D will divide BC, the base, into 2 equal half, or basically D is going to be the midpoint of this thing. So now BD is going to be what? BD is going to be half of this 2 plus 4 root 3, which is nothing but 1 plus 2 root 3. Now we know the opposite side, we know the adjacent side. We can find out tan theta or tan of ABC is going to be what? It's going to be opposite, which is 5 minus root 3 upon adjacent, which is 1 plus 2 root 3. And of course, they're asking you to write in the form of C plus D root 3. That means what? We need to rationalize it. So we'll multiply by 1 minus 2 root 3 and we'll divide by 1 minus 2 root 3. This is going to be what? So in denominator, what we'll get? We'll get 1 square minus 2 root 3 square. And in numerator, we'll just make this as 2 brackets and I'll multiply 5 with the first bracket, 5 with the second bracket, 1 minus 2 root 3 and then minus root 3 times 1 minus 2 root 3. Finally, in denominator, what I'll get? I'll get 1 minus 2 square is 4. 4 into root 3 square is 3. So 4 into 3 is nothing but 12. So it's going to be 12. Now here, it's going to be 5 minus 10 root 3 minus root 3, and minus root 3 into minus 2 root 3 is nothing but plus root 3 into root 3 3, 3 into 2 is nothing but 6. So we'll get like this. See, most of the people make mistake here only, like multiplying this minus root 3 with minus 2 root 3. So just make sure it is going to be plus. 5 plus 6 is nothing but 11, and minus 10 root 3 minus root 3 is nothing but minus 11 root 3. Just like minus x minus 10x is nothing but minus 11x. Upon 1 minus 12 is nothing but minus 11. So what I'll do, I'll just separate it from the numerator. 11 by minus 11 is nothing but minus 1, and minus 11 root 3 upon minus 1, minus 11 is going to be plus root 3. So the answer is going to be minus 1 plus root 3, or you can write this thing as root 3 minus 1. And this would be our final question, the last question which we'll take. It has the geometrical properties of surds. Okay. This would be our question number 6 for indices and surds. And here what we will do, so they are asking you to find, obviously it's a trapezium, they have given ABCD in which angle ADC is 90 degree, AB is parallel to DC. It is given that AB is equals to whatever, these are the values they are given. And they are finding it, they are asking you to find the perimeter of the trapezium. For that we require BC. So we should know a little bit of geometrical properties of trapezium, and then we can figure out easily. The thing is, we need to find this BC. So what I'll do, I'll just draw one perpendicular from here to here. Now, AD is nothing but, let's say this is BM. Okay. AD is nothing but BM. So therefore, BM is also going to be 7 plus root 5. Also, as you can see, ABMD, like basically I'm talking about this thing, it will form a rectangle. So therefore, this much would be how much? This much would be 4 plus 3 root 5. So in short, this MC is going to be how much? It's going to be MC, I would say. MC is going to be 11 plus 2 root 5, the complete DC length, minus, in brackets, 4 plus 3 root 5. Always use brackets. So we'll get what? We'll get 11 minus 4 is nothing but 7. And 2 root 5 minus 3 root 5 is going to be minus root 5. So this is what I'll get. Now we need to find this BC length. So we can use Pythagoras theorem easily. So BC square is going to be what? It's going to be BM square plus MC square. So I'll just put the values 7 plus root 5 square plus 7 minus root 5 square. So which is nothing but 7 square. So a plus b whole square, you know it. It's going to be a square plus 2ab plus b square. So 49 plus 2 times 7 times root 5. So 14 root 5 plus 5. And then here it's going to be plus 49 minus 14 root 5 plus 5. So in short, what I'll get 49 plus, this 14 root 5 minus 14 root 5 will get cancelled, and I'll get finally 49, 98, 10, 108. So we'll get 108. But BC is going to be what? It's going to be square root of 108, which can be written as under root 36 into 3. And we know that square root of 36 is nothing but 6. So it's going to be 6 root 3. This would be the value of BC. Now the perimeter is going to be what? We don't have much space, but it's very easy. So perimeter is just sum of all sides. So we'll add 4 plus 3 root 5 plus 7 plus root 5 plus 11 plus 2 root 5 and finally plus 6 root 3. And if I add all these things, I'll take the numbers together: 4, 7, 11, 22. So this is going to be 22. Okay, then we have 3 root 5 plus root 5, 4 root 5 plus 2 root 5 is going to be plus 6 root 5. So we'll get plus 6 root 5. And finally plus 6 root 3 as it is. This is going to be the perimeter of the trapezium. Now they are asking, find the area of the trapezium, giving your answer in the simplest third form. Simplest third form, so maybe we'll have to rationalize. I don't know what we have to do. Now, they're asking you to find the area of the trapezium. So what I'll do, I'll just divide it into two halves. This would be the first part, this would be the second part. Area of triangle plus area of area of rectangle. So area of rectangle is going to be what? So area of rectangle, I would say, plus area of triangle. Okay, so area of rectangle is going to be what? It's going to be 7 plus root 5 times 4 plus 3 root 5 plus area of triangle is going to be half into base into height. So half of MC into BM. So MC we already found, which was how much? MC was 7 minus root 5. So 7 minus root 5 times 7 plus root 5. Oh, this is easy. Again, we'll distribute 7 times 4 is nothing but 28. I'm just doing it directly because we already did a lot of. So 7 plus 3 root 5 is going to be plus 21 root 5 plus 4 root 5 and plus root 5 into 3 root 5. So it's going to be 3 into 5, which is 15. So at the end of the day, I'll get 28 plus 15, which is 43, plus 25 root 5. Of course, we need to add this area of triangle as well with respect to this thing. So it's going to be half into a minus b, a plus b, a square minus b square, 49 minus 5, which is nothing but plus half of 44, which is nothing but 22. So finally, I'll get 43 plus 25 root 5 plus 22, right? Which at the end will give me area as 43 plus 22 is nothing but 45, 65. So 65 plus 25 root 5. So that's going to be the answer. Now, there are so many questions in the past papers. So I'll just discuss some of the questions which can just give you an idea of how you have to deal with it. So see, as you can see in this equation, obviously they're just giving you to rationalize it. It's very simple. Here we have cos ABC is equals to minus 1 by 2. So they have given this value as minus 1 by 2. And you need to find this AC. So what you will do, you will just use cosine rule. We know that cosine rule is going to be what? It's going to be AC square is equals to AB square plus BC square minus 2ABBC into cos of ABC. We know cos of ABC, we know BC, we know AB. We can put all the values. At the end of the day, you just need to simplify and get the value. Sometimes, yeah, this is the same question we have done in the third form, like something x and something, like you will get an integer as well as the third part. You just have to equate and get the values of the constants. Then here also, see, it's all about simplification. To the power of minus 2, little bit of indices, you just switch it, you just square both the things, you do rationalize, and you get the answer. There are some log questions which I have. So some of the questions are like logs and all being added in few things. Yeah, here also see z is equals to a plus z square they have given. So you just have to square this thing and again equate it to something integer and root 3, and you just have to find the value of a and b. Then see, whenever there are 3 terms, no, always remember it has to be a quadratic, no matter what. Whenever 3 terms are there, like, or maybe something plus something is equals to 0, then do something and I mean just make it into a quadratic form. It will become a quadratic. Like here also, if I just multiply by x, I'll get what? X square plus root 2x minus 4 is equals to 0. Now you just have to find the roots of this equation, right? You can use minus b plus minus under root b square minus 4ac upon 2a to get the values. Then this we have already done. See, again here 7 to the power of x into 49 to the power of y is equals to 1. So as you can see here, we'll have to write this as 7 to the power of 2y, this 5 to the power of 3, and so on. You just have to write left hand side 7 to the power of something, right hand side 7. Here we have 1, so this is nothing but 7 to the power of 0. So anything to the power of 0 is 1, and then you can equate it. This we have done. This also. See, again 3 terms, quadratic. As you can see in this equation, 6x to the power of 2 by 3, 5x to the power of 1 by 3, just substitute x to the power of 1 by 3 as y. So the equation would be what? It's going to be 6y square minus 5y plus 1 is equals to 0. Solve the quadratics, put x to the power of 1 by 3 instead of y, get the values. Now see, they have given some values in sine 30, cos 30, tan 30. What you have to do, you have to, they have given area of triangle and they are expecting you to find the exact length of AC. So what we'll do, we'll use that formula. That is, area of triangle is nothing but half into AB into AC into sine of 30. Sine 30 they have given, AB they have given, AC is what you need to find, area of triangle also they have given. So again, you have to just switch here and there, and maybe you will get something in root form and denominator. You just have to rationalize it and get it in the simplest form. See, I think it's the same question. Get repeated. That's it. That's all you have in indices and sorts.